far in the training. Module 1 was about LeoNet variables, float, integer, string, boolean. It was about how to create your own function. It was about different operators and how to help yourself. And we also studied the one collection type, lists, to store different variables together in a list, square bracket, square bracket. Module 2 was about conditions, be honest, Kanon, and putting these conditions inside each other. We could do the if game for that to see LeoNet conditions combined. And loops. And I think loops has been the most challenging part of modules 1 and 2. Loops, the while loop, while something is true, it loops, and the for loop, for a given sequence is loop. And we, at the end, shortly also discussed about the LeoNet error types. Module 1 na module red, but basic grammar na Fidel of Python. Now, module SOST will be about different collections modules, but especially data, importing and exporting and processing data. And we'll be using air quality data as example for me. But I hope at each moment, the examples that I show, that you realize or that you start thinking right away, how can I use this for my data? Today and next week, module 3, and the week after that, Kamashka and module 4 about plots. So we start today with module 3, and that introduction gave again also time to enter. Perfect. This module will start still, actually that's a bit still part of your basic Python grammar. Besides lists, 2 other collections, so options to store multiple elements inside one, tuples and dictionaries. And after that, we're moving to modules, your own module and other modules. And especially NumPy and Pandas collections and functionalities, things made by other people that we can use very well. And based on NumPy and Pandas, we can move into importing, altering, and exporting data. And at the very end next week, how to work also with time in Pandas. So that's the plan of this morning and next week. So the idea is that from now on, every week, under but road base house. So if today is not clear, you can come tomorrow again and mega under a program. And then next week, road base house is the second part of module 3 week after that. So only mornings. And part of module 3 in the slides is also how to work with NetCDF data. But that is not part of the module 3 program, that will be part of a bonus day that will be offered just after the thing. That is fully on multidimensional data and NetCDF data. So that is not part of today's for next week's program. So let's start right away with built-in collections.
This one is not working.
What?
Yeah. I try. Yeah.
Oh. Okay. So I hope for the people that finished that joined the training that you still remember to open Spider. And just like always with a new module, what you can do is at the start make a new script. So Control N, make a new script, and Control S, save it as in your folder projects. M3 code file. Make a new script. But actually today we'll also be working with a lot of micros. Built-in collections, tuples and dictionaries compared to this. Collections. Earlier we've seen the built-in collection list. That was with square bracket open, elements separated by comma, square bracket close. We will discuss 2 other built-in collections, tuple and a dictionary. And later on in this module, we'll also discuss some external collections. NumPy, array, and Pandas data and sequence. These 2 and lists are part of the original Python. So we use Python LLM. These 2 are not directly part of Python. They are made by other people. You can import their package. Let me quickly get a laptop while I need. Do you remember which level? No. Or do you remember? You can also move to that because okay, comparison to list, tuple and dictionary. I hope you still remember with the list is very flexible. I didn't know you can easily put things in there, you can easily append, you can easily overwrite, say, list, put source, later. Tuples are similar to this, as in that they are also a sequence, a collection of networks. If you give multiple networks, it automatically gets index 0 as it is. If you have a sequence, Syntagram, Python automatically creates index. Positive index 0 is kind of and negative minus. Tuple and list exactly the same. Negative. The difference of a tuple compared to a list is a tuple is immutable, meaning that you cannot change a tuple. List is unflexible, and that what you add again. You can quickly change it. Tuple, safe. You can only make a tuple. If you then want to change your data, you cannot change tuple, so you need to make this tuple. You can never change a tuple. With a list, you can create a list and then say, oh yeah, it's actually unlimited, and just change it. Or you can just say, add this to this, add this to this. With a tuple, actually, you make a tuple, beyond later tuple, you make a tuple. And a very important practical difference, list is square bracket, tuple is a non-bracket. Yeah? So, other brackets. Dictionary. Similar to this, well, they're a collection of objects, and they are mutable as well. A list is very flexible, you can easily change it. A dictionary, you can also easily change. But the big difference is the following. With a list and a tuple, index is generated automatically. Index 0 is there. With a dictionary, index is not generated, but created by the user. In other words, if you put Mr. Nugget into a dictionary, you have to put Mr. Nugget now Mr. indices, symmetry. You have to think of the symmetry yourself. For some circumstances, that's very nice. Dictionaries are important, but the most important practical difference is, of course, lists, square brackets, tuple, normal brackets, dictionaries, curly brackets. So we're using all our different brackets. And I think we don't have more brackets. Besides that, we have, of course, the quotation marks, which explain Python that it's a string. And so everything on your keyboard is used. List, normal bracket, tuple, curly bracket, dictionary. Quick thing about a dictionary, why is it called a dictionary? Because you create index, and that's called key and value yourself. It's always a pair. That's the same in a dictionary. In English Amarinha dictionary, there is not zero, abad, and salami. It's not calculus with index 0 or something. No, it is father, abad. Hello, salam. Yeah, so it's a key value instead of Uten value. That's a big difference. And that's nice for dictionaries because in dictionaries you can store a bit of information. If you have missed temperatures, in a list, it's temperature 0, 1, 2, 3, 4. In a dictionary, you can say it's temperature, Pulpo, Jamo, Nacha, Main, and Abai. And so you can store a bit more information in a dictionary. Good. Let's move to how to create a dictionary, how to create all of them. It's very easy, as you can maybe see in the right upper corner of my slide. We'll be using one of my scripts, M3 list to dicts. So from your folder code, open M3 list to dicts. And first of all, creating. Creating an empty tuple, you can create Bible tuple, then it's just open close. If you have butja and value, that's you just have to remember. Butja and the then you have to include a comma. You cannot say open value close. No, you have to say open value comma close. If you have multiple values, then it's just like a list. Open value close. But of course with a normal bracket instead of the square bracket. Dictionary, you can make Bader dictionary, curly bracket open, curly bracket close. With multiple items, is curly bracket open, key 1, your own index, colon, value, comma, key 2, colon, value. So it's always a key, colon, value, back. Channel, colon, hiatus, comma, main, colon, accent. And so that's how you create it. So the dictionary takes a bit more time to create because you have to create the index yourself. Yeah, the only important thing of this, I want to stress out is duplicate keys are not possible. On a dictionary, we let it be channel change. Just like in a list, we let it be index 0, but you andere index 0. In a dictionary also, but you andere index channel. Yes, so we can create grades of 5 students. Let's say we have grades of 5 students. We can put them in a list like this. We can put them in a tuple like this. And we can put them together with their names in a dictionary like this. So that's a small example. We can just select it and run it. I hope for once finished 4 weeks ago that you said remember to run it with this. Select run selection of the 9 and that's the same as F9. And then now we have the list, my list, with the tuple, my tuple. Okay. And we have the dictionary. All of them the same information, with the big exception, of course, the dictionary, which we also have to sync because we created the indices outside. Yes. Now, how to move into there and get something? With a tuple, that's very easy. A tuple is exactly the same as this. Slicing is possible. So if you want to Majoria sauce Kutter out of the tuple, you slice with 0 SK sauce. If you want Sostenia nugget, you slice with Goulet. So, how can I get Hirut's grade out of the tuple? tuple. How do I have to slice to get the root grid? Three, zero, three, three, like this?
Yes.
Like it. Just remove. Like this. Yeah, I think so. Lekker enough. The root other than you lekker enough. From a tuple gets automatically index 0 as got something. Other than you lekker index source. So tuple and list exactly the same. How do you get things out of the you get it like this. If I only want Majoria would left footer, I can say SK left, give me 0 nada. It's possible with a tuple and with a list and with a tuple. Yeah. So tuple and list and dictionary is the different. A couple of things that might be relevant. If you just want one element, for example, I want the Abel grade, then you don't have to think, oh, Abel something and grade. No, you just say, I did Abel. Because your Abel grade index Abel number. Not index 0 or 3, no, it's index Abel, the one you created yourself. So that makes the dictionary quite nice. If I now want to root grade from the dictionary, I did good. I just want here you root it. So that's nice about the dictionary. If you want a quick overview of all keys are the indices, you would have symbols. Then you can say my dot keys of those. And you get a nice overview of symbols. If you want an overview of only the values with this, well, then you can say dot values. And if you want a combination of key value pairs, then you can say dot items. So my keys will give me min keys up. My dot values will give me items will be a combination of everything. As you can see, they are stored in 5 tuples. Just quickly to flex your brain, this gives you some collection. Any collection you can turn into another collection with some function. For example, earlier we saw functional range. You can turn the functional range into a list with this. So I can also say, put this into a list. And if I save this, I can this, then I can say, oh, this list 0. Then I get item list 0 is a tuple. Out of normal bracket, tuple. So if I want only this dynamics, I'm just repeating things in the module and to show you. The more you practice, the more tools you measure and combine, in the more different ways you can get to it. Most importantly, tuple slicing exactly the same as this. Dictionary, you use of course the name, and there are some built-in methods to get some other properties. Good. Now, if you would like to change it, changing a tuple is not possible. So, quick example on the board. If I have tab 1, which is a tuple and collected source, I cannot say tab 1 0 unlimited. If I would like method collected source, I should create it. So I could say tab 2 is the tuple of unlimited and then include the comma plus the other tuple, but only count. And so I'm building a new tuple based on my old. To show you this quickly on the screen. If I have a list 1, 1, 2, 3, I can just say this 1, 0. List flexible. If tuple, put 1 is 1, 2, 3. I cannot say tut 1, 0 is because that's not supported. In a tuple, your data is safe. You cannot accidentally. If I want data tuple, I can say, well, data tuple is 1, 2, 2 is a tuple fundamental, tuple fundamental, and finish of file hydro tuple. Just 1, not moeilijk. Count. Which is fundamental and bullet free. Yes? Just to show you that behind data tuple to figure out this tuple. Now the dictionary is the easy one. Let's say there is dict, we have Hirut. If we want to change the grade of Hirut, we can just say my dict Hirut, and then say, well, I want it. And then we just change the Hirut. If we use a dictionary with some new key, Leia so, my dict Ashenaki, Aun, then if we say my dict Ashenaki equals similar, then it's just added and added. So if you use a new key with a new value, it adds. You can delete the value by saying del with key, and you can enter the full dictionary and delete it. That's not absolutely relevant, but let's show how that works. A couple of changes that we want. If you want to change multiple items at the same time, so here you can change one item, just say this here. But if you want to change multiple items, you can use the built-in method dot update. Update, and then you can use supply all kinds of. Let me give you an example. In the section change. If we want to change Abel's grade zit in je grade. First, shall we see index 0? So in the list with Amkalana, we say just 0, Amusida 0. Amistamista, but now it's become Amusida. With a tuple, we cannot change the tuple. So we just have to create a new tuple, starting with this, plus the rest of the array, and you just say, oh, we override. With the dictionary, it's very easy. We can just say, Abel, Amusida. If we want to append some grade, for example, Adi's grade, Ahmed, we can just say with the list, my list will append. With a tuple, you cannot change a tuple, so instead you take the old tuple and do it plus additional tuple to create a new tuple. With my dict, you just use Ahmed, key Ahmed Yellen, but you supply value, so you use key Ahmed. If you want to delete, for example, Kirubo's grade, with the list you have the index pop, je Kirubo grade onto the source, then you have index bullet. Tuple cannot change the tuple, so you have to make it a bit complicated. I want Majemari OLED and I want Macherisha OLED. And so you get parts of the old tuple and create a new tuple. Deleting the dictionary again, very easy. Multiple grades, just add this to the end. Add these to the end. With my dict. So update, you just supply some other dictionary with Viru, so key value, key value, key value. This shows you, and whenever you I want to create one of these, you need to check these examples. By practicing yourself, you will learn. So at this moment, I list Mr. Grid. Now I can see minus 0 exhibits. Creating a tuple. On the Abo grid, so this repeat add something to the end. Add a new one. We can delete it. We can add substitute and update the dictionary to include also real music. So now I have this list, this tuple, this dictionary. Yes? Examples are so when you need to start using it, you can check this again. Now, quickly about built-in methods. I hope you remember still, you could see, for example, the built-in methods of the list, I think here, my list. And then you see, oh, when I have clear, I have copy on the map. Or you could do my list dot to see all these methods. Yes. Those are the built-in methods to lists. Similarly, tuples have built-in methods. So can you tell me min built-in methods? The tuple. So check for my tuple min methods. Yeah, that's how that. So if you want to know the methods of a tuple, you need to start with some tuple. We have a tuple, tuple now. If we want to use some method on my tuple, you can do dot top, but you let the methods out. Only methods to find something in them. Syntaxische aanstaan, is statistisch data indexing. So for a tuple, there are only methods to find in there because the difference with lists is there are no methods to mutate a tuple. You cannot change a tuple, so there are also no methods to change a tuple. For a list, there is insert, pop, move, append, the two tuple variation, tuple save. So that's a tuple. For a dictionary, we have a bit more built-in methods. Because there we have methods to find things, but also to change things. Clear it, copy, get things from there, get no viewable keys, pop something out of there. Update, of course, with the update you can quickly change multiple values. So those are the built-in methods. So to summarize, lists, tuples, and dictionaries. Lists and dictionaries are very flexible. Easy to mutate, change, add, or delete. Dictionaries give you the opportunity to use your own keys instead of a standard index. Tuples, on the other hand, are safe. There are no methods to mutate. They are also, for that reason, used by Python itself if for some reason multiple items need to be returned. You might remember this. Just watch my screen. I want to take you back to module 1. In module 1, we created this function, function group f, which took the highlight master but and then it prints. At this moment, I'm getting nothing from it. I'm only getting a print, but nothing is checked. So that's the return, not mentioned. I could say return, and it would, for example, be interesting to return groups, but also if you return the name, roulette. You might still remember roulette return action. I can also say groups. Because instead, what I can do is comma. If I now use it, roulette and return. How are they returned? As a tuple. If Python needs to return multiple items, it automatically selects the tuple because the tuple is set. Tuple cannot be changed. So that's the selection that Python always makes. And we'll dive in that for a small moment. Because that leads me to multiple items and unwrap. And this I explained already. Finish to developers in the group. But now I want to mention it again. MyDate.items. Returns a collection of key values. And as we already saw, these pairs are stored in tuples. And we just saw if you return multiple items from a function, it's also returned as a tuple. So one other example of that I have inside this tuple dictionary, I think. Here. Unwrap. I create one other silly example, the multiple return function. The only thing this multiple return function does is it returns substance. So if I use this function, it returns substance. Because that's the only thing this function is. This function returns substance string. And now it gets important. Any collection of multiple items can also be unwrapped. You can directly assign it to multiple variables. Last week I told you that I assigned that. So source items limiter. Anything that is returned I can say. So I can say, for example, output is this, and then output is my source limiter. Yes? But if I want the source limiter directly in source image, instead of output is this, I can also supply source image, for example, var 1, var 2, var 3. Source image, not source limiter. Then var 1 is directly generated var source limiter. Source limiter. In other words, let me combine one other example. I can do that with any collection. I can create list 1, which is two floats, 1.0, 3.0. List itself and the same roulette negative. Or I can do exactly the same with 1, 2. Well, 1, which is directly. In other words, if you have a misdemeanor, you can store them in undersea. If you put this misdemeanor in normal brackets, you put it. If you put it in square brackets, this a misdemeanor undersea collection. Alternatively, you can decide amistis. And then you directly get them all separate. Quick question, what is the program? I do this. Why do I get an error?
መጀመሪያ ያለው value ዋና value
Three values, two names.
Yeah.
So Python does not know how do you want to distribute it. In other words, Leonard hebben, Amici hebben, Amici met each other, collection. Amici with each other, yeah, they will be so different. But anything different, actually. Now this tool, unwrapping, is used at many locations, and in Module 4 we'll be using it also a lot for plots, etc. But let me now give just one application example. This ID you can also use in a for loop. For example, if you want to use both key and value from the dictionary, mydict.items. What does it give? If you type yourself mydict.items, if you type this one, what do you get? And not only the values, you get all key item
plus the grade of
yeah, so you can get an overview of all. That's it. More importantly, you get a collection. As you can see, it's collected together. Here it opens one square bracket and it only closes here. Collection. Je hebt collection. Centimeter uit, je hebt collection. As you can see, in this collection, there's 1, 2, 3, 4, 5, 6, 7. So, let me ask you this question. I can loop over any collection with the for. Earlier we looped over function range, or function string, but I can also loop over this collection. If I do this, majority iteration I manage. I'm looping over, if I loop over range higher, then I put 0 is constant, then majority iteration I will be 0. Now I don't loop over footage, I loop over this collection. Majority iteration is majority and negative of this collection. Majority and negative of this collection is this. Let's check. I loop over this collection and each time I print each item, majority item. It's abo, bullet and yes, bullet and yes. This I can also use to unwrap. Because majority iteration I remember no tuple abo, comma, in other words, majority iteration I will let them I want you to make an understand. That's correct. We'll let the nigger, I can also provide on that. That's what I do. Key, comma,
value.
Majority iteration, key minimum.
The key is the name. Then it moves to
Showing unity iteration. Value. Sostenha iteration. Key minimum. Yeah. And value. Here I keep it in one. Here I directly in one. And that's nice in this case because now I can make a mutualized print statement. I can say each iteration do something, print the grade of plus key is, and then put the knows where I have to print this thing. So the more you practice and remember different tools, the better code you can get. If you have some collection with each time a tuple of 3 air quality parameters, well then you can loop through this and keep them in a collection. Majority iteration tuple of day 1, temperature, relative humidity, solar radiation, for the 10 year, or you can each iteration directly unwrap them into source specific and do some calculation for your model based on that calculated rainfall. So I'm just showing you the tools, and at some point you might run into your own application. So to summarize it in words, this example, my digital items creates a collection of tuples. The for loop loops through this collection with every iteration you get an item of this collection. Knowing that this item is actually a tuple of a letter negative, we can directly unwrap it using key command. As a result, every iteration we don't get a tuple, but we have one key and a corresponding value that we can use to print, to calculate, to put on the graph. Okay, I'm going to give you very small time to practice, cement, data, just to get things into practice, and then we move on to more interesting stuff. So let's take SK soft root to do the following. See my focus still here. Just see how far you get. Given measurements for temperature, relative humidity, and carbon dioxide, I am using the scissors. Create tuple 1 and dict 1. So create, store these values into tuple multiplication. Think about how to get the relative humidity value out of that. Change a couple of things, change the temperature value, add the BMP temp value, remove carbon dioxide, and this is mapping. I'll quickly show that. Yeah, but just for 8 to 10 minutes, take your time to practice this. So in the script, assignment, write the code below here. Create a tuple on a dictionary, change something, add something, remove something. And these tasks follow exactly also how we went through the script. So creating, well, you can see an example of creating up in the script. Changing, see examples of changing. See the example and do it yourself. Good. Okay, I said only short time for practice. So I think most of you need to realize how to make it, and the rest we can quickly, as a recap, go through it together. Source the values, if I want to put them into a tuple, very easy. Just source the elements divided by comma, square brackets, non tuple. To put them in a dictionary takes me a bit more time because besides the values, I have to give the keys. Key value transfer, key column value format, key column value, key column value. So in this way I can create top one and dict one in which environmental data is stored. Now let's say I want to print the relative humidity value. How can I print the relative humidity value from top one? How to get only the relative humidity value?
One.
Bullet in je maar let op niks.
Schema.
Relative humidity is bullet in je. Imagine you put 0, so this will print answer. How do I do this for dictionary? Also the square brackets, that's the same. And then the name argument. Yeah. Alright. So that's quite different. But this one is logically easier. You don't have to count since in your all many counts. No, it's just RH. I don't know since in I don't. Now if I would like to change the value of temperature. So I want to change 25.6 into 27.8. I cannot change this. So I have to create a new one, which is 27.8, comma, and I could type rest, or I could just say, I just take the rest of the old one, just draw out the rest. What do I have to write here? If I want everything at the end of the beginning, okay. Yeah. Or magenta in this case. Yeah. But answer is a bit safer because we won't know the Gemini we supply ourselves. Remember, for a tuple, supply a comma here. Because otherwise Python does not understand that it's a tuple. That's well, because the brackets are also used simply. You say, for example, 0 in brackets. It's just 0. Because you can say 0 times 3. But if you want a tuple of 0, then you explain right now the 0 needs to be a tuple. Go to 0. Tuple bridge is 0. So this comma is flagging now we want to switch on. So we create a new tuple by saying this tuple. With the dictionary it's much easier. How do I change the value of temperature? So yeah, in my case it's big one, yes. So this would just give me, okay, it's 25.6. But I can at the same moment, yeah, exactly. Say no, it's actually something else. 27. And now, this one. This is just changed. That's the dictionary is very easy to change. To add something for tuple 1, we cannot add a value, so we have to say tuple 1 is the numeric tuple plus data tuple, which is value of 10. This one, to add a value with Antolano, I can just say P 10. If I now say this, why do I get an error? I use this one, PM10, error, then
There is no.
it is not that. Exactly, we get a key error. Yeah, there is no key pin. Then again, if I say, well, there is, I want to tell it to the button, it's happens to be as an then there is no error. And it just adds. And now, that's just very easy to add. To delete something for a dictionary, you can say delete this one here too. For a tuple, it's a bit complicated. We have that one, arrest footer, and we want to remove this one. Oh, we have to just create a new tuple, which is Majimari left footer. How do I get Majimari left?
One.
Escort.
SK?
Escort.
SK. Because SK is giving everything SK 0 complete. So this is giving me 0 and 1. So in this way I get 25.6 Hamza. And then after that I need that one curve source. Giving everything curve. In other words, I skip this. So now it's removed. Yeah, and the new reference. Totally relevant for now. But this just shows you for other data as well. Now, why did I still start with a tuple and dictionary? Tuple and dictionary are still actually part of the basic Python grammar. Tuples and dictionaries are used a lot, just like this, in the later packages that we encounter. So later on in Pandas, you have to create some data frame, which is some table format. The way you create it is by supplying the data in the dictionary. Later on in NetCDF, if you want to explain the dimensions, you have to supply that as a tuple. So there are three basic collection types: lists, square bracket, tuples, long bracket, dictionaries, curly brackets, and all of them are used all over Python. So now you at least heard of them, and the moment that you know them. Let's now move into modules. And we'll start with our own module. Just for a second, you can open M3 on module by one. And then you will see some familiar functions. Or at least average of 3 and group division should be familiar. Parameter average is familiar for the ones that did cite. We have a script file with different functions in it. M3 on module.python. A collection of code and functions in other files is a module. With the import statement, we can import modules so that we can use contents of the module. Arif now, because then you can make one big script in which all your functions are for some model that you use in your paper. And then you, in a Lena script, you can just write import behavior. So you can start to organize your code, separate it over different code, one script with all functions, and then another script in which you say, well, import those functions. So your code becomes more structured. So with the import statement, we can import modules so that we can use the contents. But first we need to tell Python where to look for our own module. So we need to add this position to the so-called Python path. Do the following, the Python path manager. Move to Tools, Python path manager. So click on Tools, Python path manager. And then add your folder code to this. So say add path, select the folder code, click on select folder. In other words, tools, Python Path Manager. So you are in yes, add path. Select your folder code, click on select folder. Then it's here. So if you've done that, hit OK. Yeah. The module does not really matter. It's now about
አይደለም ቱልስ ውስጥ ገብተህ ከዛ ፓይተን ፓዝ ማለት ነው። ከዛ አድ ፓዝ ከዛ በኋላ ፎልደር ምረት የቱ ጋር እንዳለ
I selected for the code, single click, and then select. Now it's there, and then click on OK. So also in your case, it's not, but I do not yet see it.
I put some define
Only now the
this one.
yeah, so you can click it OK. So you can okay, let's see. If you did this, then do the following. Do the following in the console or in some new script, but not in the script M3 only. So, for example, do it in M3 code.py. Do the following. You can write import M3 on module. And some of you might get an error, then that might mean that you first need to restart the file. It should normally work. Yeah, and then run it. Yeah, so if you run it, if you run it and get no error, that means that you just imported everything from M3 or modules.py. And that was possible because we explained to Python in the folder code are also some modules. So Python Path Manager at path code, in there it starts looping, and then it finds indeed M3 or module.py, and then it imports it. How could you see all attributes? Do you remember the function to get an overview of all objects? Function dir. And the function dir told us all attributes. Now we can use dir M3 or module to see which attributes are there for M3 or module. Dir M3 or module. At first on your Python method, but after that indeed our functions. How could we access attributes? Let's say in M3, and anything Python knows you can dot dot. Now, function group division, I can select the function group division, bracket open, yeah, indeed, I my function group division. And then I can say, and now my function works. So very nice, this script file is very clean. I only import something, and then I can start using the functions. And somewhere else, I have the code of all my functions. So I can start organizing my code very well. I can make one script of it, functions article 1, one script of it, functions article 2, and then just whenever I want to work on article 1, I can say import for one function. Or if I want to work on it. Now, at this moment, we each time have to type. So we import M3 on module, and to use the functions, we need to use M3 on module dot group. But we can also make this addition. You can also say import M3 on module as O M. In other words, import this one and give it layer C. Give it the name O M. That's very nice because then I can start using all filters. And so my code is shorter in this way. Now I can use average of 3, 3.5, I get a million module 1 average of 3 codes, which is stored in this file, which is imported here under the name M. Import S. Now with this one, I just import Mulu and it is stored under this name. So here it's stored group average, parameter average, or a group division parameter average and average of 3 are stored under this. So I always need to use M3 on dot or OM dot. They are colored. I can also just import only group division with the following. I can say from M3 on module, please look in there, input average of 3. So then two things happen. Only average of 3 is imported and it's not anymore stored under M3 on module. But it's just directly imported. I do not import this module, I import the function itself. So if I do this, I can directly use average of 3, the function itself. So rich island yellow here, Moodle weights are here also in the lesson. Here, rich. And that, of course, I can also make a bit more efficient. I could also say import average of 3, but we follow this stupid name way too long as AOT or something. And then, of course, I can use AOT, which is now also my function. So that makes it more and more efficient. I could also decide to import multiple at the same time, so I can say, well, I have this one and also group division. Then I import the letter. No, that's not possible. And it gets a bit. And finally, I can say, and then I'm going to ask you a question, from M3 on module import Hulu. And now the question. What is the difference between this one. This is import module. This is from module import Hulu. And then this.
And enter.
And then
They are different.
And what is the difference?
In the first case, they import all the modules. But the second one imports all, for example, it may be function only. It imports the function
Yeah, I think.
from that module.
Yeah. What you say is correct. And it basically comes down to this. If we use this one, then Moonbase set up. So we always have group division stored under .m3. So if we want to use group division, we need to say n3 on group. If we say from this module import Hulu, Moonbase set up, so we can directly use group division. It's not anymore stored under n3. Just group division. Average parameter. And so there is just a choice you make. Keep it together under n3 on module dot, or get them all, get everything to there, not anymore collected together. Well, these tools build up to the use of modules from others. That is where Python is much stronger. But just to quickly ask you, Jägers now is, can you tell me with which command can you import the function parameter average under the new name PA? So in M3 on module, that's parameter average. What do I write here if I want to get that one specifically in a new name? So in this, in M3 on module, this M3 on module. Source function. Now I want to sustain a function, gotcha. And I also want to give it legacy PA instead of parameter. How do I do it? So from M3 on module, import
Parameter of it
parameter
as PAV.
X V. And now I have PA, which is some parameter average, and that happens to take a parameter temperature with some values. But more importantly, indeed, I have got it from another script file and I've given it a name that is much shorter. And that builds up to modules from others. If you create your own code, you might distribute it over different scripts and then import them as modules. In that way, your code becomes Python, open source, Malet, all around the world, people are developing modules. So all around the world, people have used the Python grammar Fidel to write Ethernet functions, and combinations of functions turn into modules. So a lot of work is already done. How can you get that work? Well, you need to make sure that it's on your computer, and then you can import it. Now, Anaconda has already installed many modules for you from other people. And Anaconda decided to make three modules with Tamas Verlangen for any research. So it's directly on your computer. They are also called packages. If you want to use them, you need to import them. So they are on your computer, but not directly part of your current Python. if everything is always part of your current Python memory, your memory is full. You don't want always to create tables, graphs, and do scientific calculations. But someday you are especially busy with the calculations, well, then import the package for calculations. Another day you are going to make graphs, then import the package for graphs. Only import what you use. Now, two very important modules for any data scientist are the modules Pandas. The module Panda is for loading, processing, changing, and exporting tabular data. Meaning, the guys at Pandas have programmed it very well that you can work with data just like you are used to in Excel. As in a table, with columns and rows. And that is Pandas is very good. Besides that, the package NumPy, that is, I think, numbers for Python, for scientific computing. Any mathematical formula you can find in it. So let's check them for a moment. We need to import them, so you have to say import pandas, and what you always see is made short. So we are going to directly rename it as PD, so that we don't do that pandas dot and then PD dot. So import pandas as PD, import numpy as NP, and then check dir PD, but also help PD with information and dir NP. So do this and tell me eventually dir PD mun functions alle dir NP mun functions import PD. And then say dir PD and tell me minder. Zijn functies alle? Is it pandas? No. Oh, you can do one arrow up and then you see the previous one. Yeah, that was not. Yeah, so you input them and then you can just to give a quick impression, the directory of numpy min nigger. You have to check this. Yeah, so if you want to click on you can always get all the help text that is available. Well, we can check help PD, pandas. The pandas guys spend their time to make a bit of a nice help on the package pandas. Pandas is a powerful data and it's an operation library for Python. Python package providing fast, flexible, and data structures. Main feature here is just a few of the things that Pandas does well. Brazil, with their PD, you get too much to show, not too much, but a lot. And of course, if you are working and wondering what does two data, well, that was just like we did in module 1 PD dot 2 data time, you can put it into L. And then you get quite some information. The guys at Pandas did a lot of the control programming, but also they wrote a lot of the control documentation. Yeah? So if you use help on their functions, typically you get very nice information. With NumPy, that's a bit less. With NumPy, there's just they did not organize their info very well. names, you can already see bezoeleind of mathematics. For example, the sim times. How to use the sim, you can say, and then they have written. Their help text is not nice. More importantly, these modules have many functionalities and extensive documentation. For NumPy, this help text they organized a bit less nicely, but online, but on your documentation with tutorials. The only thing we will study in this module is different collections from NumPys and pandas, some mutation options, importing and exporting data, and how to work with time. And actually for pandas, I supplied also the PDF to you in your share folder Python training materials. No, based by project miscellaneous. There is the pandas documentation. Pandas has a very nice website with documentation, but they also have one they got to print PDF. I did it. And this is all the documentation. Bunch of social sheet pages of documentation on only the package pandas. Yeah? So this is not only Python, this is bunch of pandas. And why is this a lot? Because they spend a lot of time not only saying import out, but to also make very nice, quick examples. So they give example code. So from this you can learn much more useful. The pandas got any kind of data processing, so organizing the table, the data, etc. If you at some point wonder how can I do this, then just type it in Google, pandas, Python, probably you will write some good page of them that explains. I only picked up the highlights. Etc. Yes. We'll just make a quick start with the collection NumPy array, a bit more on NumPy, and start with pandas. So the collection NumPy array. For that you can open m3np array.py, and we'll be studying array basics. A NumPy array is a collection of data, just like lists, tuples, or dictionaries. Lists, tuples, and dictionaries are basic Python. NumPy array, also a collection of, but it is created by the guys of Num. So you can only use it if you are imported. This one is very relevant. How can we create an array? Length bracket given. The square bracket is this. Normal bracket is tuple, curly bracket is dictionary. So we have not array brackets. The only way in which you can create an array is by turning some other collection into an array. In other words, you can have a list 1, 2, 3 and return it into a NumPy array. That is the function array. It's stored under NumPy, so we have to say, of course, np.array of this list. From this list, array. And array and free array. Then input. Then we have a pivot over there. And then we can create array, which is the array of the list 1, 2, 3. Type of array 1 is now NumPy, and it's not a list, it's not a tuple, it's not a dictionary, it's something new. How to access an array? That is very nice, just like a list or a tuple. Slicing is possible. So Mujimari and footer of this array is also found with index. Mujimari of that footer is also printed. Let's go to that. So NumPy guys, we're smart. They thought, let's keep it easy. Let's use easy tools. So eens gaan zien aan. NumPy is the package for mathematical computations. So they make sure that they also have a collection in which you do can do very quick mathematical operations. With an array, you can conduct mathematical operations to all elements at the same time. Do you remember what happens? Let's say I list 1, 2, 3. What happens if I do list 1 times 3? Do you remember what happens? Yeah, that is upwards. With an array, there is totally different behavior. If I do array 1 times 3, I get both. It's not arrays are better than this or this are better than arrays. They just behave differently. For different situations, you want to use different things. This one is very nice because if you have 1 million temperature Celsius, you can just do them times something plus something and turn them into temperature Fahrenheit. You can just do quick calculation. Do you remember what happens if I do this with this? This 1 plus 3. No, actually, we did not specifically show this. It is an error. The plus, we could say, for example, list 1 plus another list. And then it would. So if I would like to append, I could say the list of list 1 plus list 3 is, of course, an. But the list 1 plus list number 3 actually. Arrays mathematics. Everything plus 3. So 1 million temperature Celsius, array was plus 273 temperature Kelvin. So that is with arrays with aan Yeshiva. So that happens here. Array 2, I can create, let's say, array 1 times 3, and array 3, I can create the same array 1 plus 3. Mathematics are possible. Any mathematical operation you do on array, it happens on all the elements at the same time. Besides that, you can also do logical operations. And that's where it really gets it. You can also check all elements of the array to get a new array with booleans. So for example, if I say I'm going to create a new array, array 1, and I say it is array 1 smaller than 3, because it's an array, the guys will not be programmed that well, a comparison will happen to all of the items. And it will give me an array of booleans. So it will give me true to false. So what will this give me? Array 1, 3. Yeah, exactly. False, false, true. Yeah, we do some relational parameter. We do some condition. It's not another, no, it's an array to it. Because it's an array, it starts comparing all elements. Well, in this case, it should be false, false, true. Yeah, false, false, true. So I can create an array of booleans, and array 4 is array 1 smaller than. With a list, this is not possible. You cannot say list 1 smaller than. That's not So that's only possible with arrays. And then the final thing I want to tell you, this is where I want to be very powerful. We'll see if the Kabuna will be an example. An array of booleans, array 4 is now an array of booleans. Right? Array of zoals de booleans. An array of booleans can be used to slice an array. Array 1, and I'm slicing, and I don't want 0 or discount. No, I want array 4. Gives us only all elements at the same position as true in array 4. In other words, array 1 sliced for array 4 gives me Lujimaria and Lujimaria. Sostenje excluded because that one's false. That is also only possible with arrays. So I can have array 1 and say, well, but I can also say I want true to false. And then I get a smaller. With a list or tuple, this is not possible. And of course, we can integrate the two steps into one step. So I could say array 5 is array 1 sliced with array 4. Or integrate them, actually, in this case, it's a bit clearer. Array 6 is array 1. As you can see, I now replace array 4 with what array 4 is. In other words, give me array 1 for which array 1 is smaller than 3. And you might start to recognize that makes it very powerful. Give me all relative humidity values for which temperature values are higher than 20. And then very quickly, give me all temperature values for which location values are abundant. Directly like abundant. We'll see that Kabuna will have an example, but this at least shows that we can slice. Now array 6 is indeed. So what will be the result of array 1? Array 1 is 2. Bigger than 2. Yeah, so this is 1, 2, 3. Combine it with a comparison bigger than true, so that will be false, false, true. Using it to slice, it will give false, false, true, but just so. But it's maybe more easier to understand this as this will simply give me everything that's bigger than 2. And so very quickly, and for Python it doesn't matter whether it is associated with unlimited. Very quickly, it filters out. Ahun, Huna, Wish, Shut. Yeah? And let's have a moment for our laptops. The restroom is open. We'll go check it out. Okay. You mean the training? So great. Nice to it. But actually, I think it's also. I have written and the luck that for me research like it's for me a bit easier to get like and then actually I like it much more if I can get the training like efficient training with more videos I like it much more than only sometimes 2 hours so I think that the question that you see also for me the training is much more nice it's also random and that's like a whole package so not only so for me it's also very nice because make that possible. Or at least you are teaching this train some of this. Also you are adding to skill. Yeah. Yeah, and for me it's very nice to especially like this training with the colleagues. At least some of the colleagues already have also like you. So it's very motivating. So that is for me it's very nice. I didn't see this like this passing on other days. Maybe right? Yeah. Yeah. And sometimes also ask the colleagues why don't you do training? Yeah, I don't know. I don't know what I copy my behavior, I think, also from what I saw in my study. And then, yeah, all my teachers is motivated by very well thought development.
John is Pandi design package is very friendly with very old module 3. Old module 3. Should I install first all the module 3 to run this Pandi and NAPI package? That's why because I got an error when I run this all 3 modules.
Which error? Oh no.
At the first thing.
But the pandas doesn't work?
No, this one is not.
Okay. In that case, I think you need to. I think for you.
ጠዋት ብቻ መሰለኝ ከሰዓት
And
ይሞቃል
the error you
ግን ቢያንስ በሳምንት ሁለቴ ራሱ ብንማር አሪፍ ነበር
but that was
ረጅም ጊዜ ስትወስድ እኛው ወር ምናምን እኮ ነው
እኔም እንደዛ ነው
I saw that you typed
በፊት
it
ነው
ወር ከምናምን ነው
because there's no
ከዛ ከወር ከምናምን በኋላ ተመልሰ ሲጀምር
ነገር ይችላል አሁን ነገር
but the M3 on module
ኔክስት ዊክ ላይ አይደለም ኦልሞስት ወር ከ15 ቀን በኋላ እኮ ነው አሁን ተመልሰን ሞጁል 3 ነው የጀመረው ስለዚህ እንትን ነው አሰልቺ ነው የሚሆነው ምክንያቱም ትራስ በመሃል ጋር ስትፈጥር
እንትን
ይረሳል
ኤክሰርሳይዝ
ስለማናረግ ነው ምክንያቱም ሌሎች ነገሮች ስላሉብን ግን ኮንቲኒየስሊ ብትማር ግን
ኮንቲኒየስ ሆኖ የሆነ ነገር ይዘታል በደንብ ተከታተላል አትሊስት
አይ ለማየት ደግሞ አሁን ፕራክቲስ አድርገን ለመጠየቅ ግን በአሁን በትክክል ለመስራት
ፕሮፌሽን ለመሆንማ በክላሱ ምንም
ቢያንስ አንተ የሚሰራበትን አናረለ ትኖችን እንትን ለማድረግ እዚህ ጋር
ሰራበት ኤሪያ ሁሉ በየሰራ ሲሆን ነው ሞሮፍ
የምትረዱ እንደዛ ሲሆን በጣም የሚገባ ማለት ነው ያለዛ እኛው
ስጋም ቤዚኮቹን ለማወቅ ራስ ፕራክቲስ ካማለት እንደዚህ
ዩቲዩብ ገብቶ
ሞር ወደ ሰማው
ያው ኢንፎርሜሽኑ የመጀመሪያ ኢንፎርሜሽን ወሳኝ ነው
መጀመሪያ ላይ ከዛ
ቤዚክ ነገሮች አስፈላጊ
ዩቲዩብ ገብቶ ወደ አንደርስታንድ
እዚህ ቤቱ እንዴት እዚህ ራሱ ወደ ማድረግ ነው እሱ ጋር ከዛ በግል የምትጠቀመው
ከሆነ ጊዜ በኋላ ቴክስት ራሱ ለሚጻጻፈው በፋይል ነው
የሚጻጻፈው
እንደዛ ነው
ሚስጥር ምናምን
የሆነ ነገር ከዚህ ሲል በፓይተን ነው በጣም ነው ዩቲዩብ ማግኘት ነው እነሱ ነው
campuses. Now, in Waterfall module, we with the group that I did the assignment with, we imported days, 50 days, 4 campuses, and we started with loops to change that and then to get the campus. Now we'll just generate this fake data right on the spot. So this data we quickly create with tools we already know and with tools from now. So this example will show you 2 things generally. How to quickly create fake data. Why would you sometimes want fake data? Well, if you created some model, just to quickly try out your model, check the sensitivity, or feed it some fake temperature data, some randomly generated data. So this data we quickly create with tools we already know and some other methods. So I'll show you how to generate data, and secondly, of course, how to get data. So, how to create quickly some random data, or this fake data. Step 1, create a list with 4 locations for 50 days. Now, so we want one list with roulette méthodisé, min location, and Arad location. So we want Amsterdam, Arad location. And besides that, we want roulette method, fake measurement data for 50 days experience for campuses. Step 1, create a list with 4 locations for 50 days. That we can quickly do with a list. Because location list, if you want to put that method, we say, make a you can just write under this list of make and school and do it times 50. The yes, that's this and then list 200 times campuses. quickly generated with lists. Step one. Step one, good sound. We create quickly a list with 200 times cards. And we do that on this line. And so we are working in three dots. Step two, to use the functionalities of NumPy. So at some point we want to say, well, we only want output which becomes main campus. This equals main campus, and we get two. Then this should be in an array, not a list. We cannot operate a list. We can do only logical operator. Well, to use the functionalities, we need to turn it into an array. That we do here. We just say location array is np.array, the function array stored on the NumPy, turn the list into that. Now, an array with so now I have this with nicely stored into array. So we have an array with Houlet-Mutter locations. Now I want an array with Houlet-Mutter. Yeah, I have random. Step 3 is to create an array with random temperature. Now NumPy has different functions for random number generation and under np.random. Under there, some functions. Now the function we will use now is np.random.randint. Why? In this function you can specify the range. It's nice for random temperatures. You don't want any random number. You want something that represents temperature. So we want, for example, between 20 and 30. If you just create some random number, then you get ambient temperatures. So the idea of this is we generate fake data just to show you the tools. But this will also show you can quickly generate fake random temperature to test your model. Now, that very quickly happens with this line. That line, and then I have 200. And let me move step by step. First of all, how did I find this function? This function np.random.randint. Yeah, this is a function, it's stored under random, which is stored under num. This is not something I knew. It's not that I took training and I learned all the NumPy functions and then I knew it. No, I simply started looking for it. How did I find this function? By just typing np.random. And then it done. What I actually did during preparation of this training was I just knew NumPy, we zoom it out. I want to know random number generation. So I started np.rand. Random. And this one put it to help. That's it. And then I found out np.random is not a function, then random this function. Okay? And then I saw a lot of different things and then I thought, well, let's just check the harness function, the random number generation. But we need to start with random. So, okay. And then I have a very nice overview of some functions that step by step I can just put into the help or just try out. And in that way I found it. And if I start using randint, I also get the help for randint. If you read this and you see these different arguments, what do you think low, high, and size mean? So the range side. Yeah. So this is how you learn Python, or how you improve it. By simply thinking I have some task, and then realizing if it's a mathematical task, most probably it will be a number. So then you can just hit mp.tab or start typing and see if you make it happen. The idea is not that you directly find the correct function. The idea is that you maybe spend first half an hour finding the right function, putting it into an output. It's not fully right one. And this one, it might be the right one. Test it until you get the result you want. And from that you start remembering some function. We do not have the time to discuss all functions of number. For each of you might want to use different functions. I guarantee each of the functions out, and you can easily find them yourself. Another way, of course, would be to type on the internet, in this case, NumPy random number generation. And then also definitely will be pointed to this function and other functions with clear examples. So we could also use help NP of random or their NP random for searching Google for number NumPy random number generator. So now we also know what the numbers 240, 290, and 200 signify. This is the low, this is the high, this is the footer. Randint only works with integers. So I'm using 240, 290. And then I get an array of random numbers between 240 and 290. It's an array, so I can directly do mathematics. I can directly divide this by 10. So I nicely get random floating temperature between 24 and 29. And that's exactly what happens. Temperature array, we let them at temperatures are min eine temperatures. All temperatures are randomly between 240 and 290. Does he get some? Yeah, this is the function with low, high size. This creates an array with random temperatures between 2 and 40. Any array, I can do mathematics too. So I can also do it directly. Divide this array by 10. So that I get nice floating temperatures. So this function only works for integers, so it needs to be created. But it's rather easy to be created. Okay, so we created our fake data. Yes. Yes, so low, high, and size. So for example, between 240 and 290. This is the lowest and highest value. And then Houellebecq met Coulter. Then you would get Houellebecq met random numbers between 240 and 290. But you can also divide this all by 10, of course. You get random numbers. So this looks like temperature. Yeah. This would be a very nice input.
Is that in that tape?
Okay, you do 24 and 29. I do Houellebecq met You do 24 and 29, so you only get 26, 25, 24. Okay. But I wanted floating temperatures. I want not only 25, I want 25.7. I could not do that with this function because this is integers, so that's why I did everything 10 times and then you learn it. Yes? Okay, so we generated our fake data. Why did we do this? To, after this, show how easy it is to take some average words. At this moment, we have location array, which is an array related to location, and we have temperature array, which is an array related to temperatures. We just generated the data ourselves, and we also just based on one array with locations and one array with corresponding temperatures, we can use logical operations to quickly obtain an average for only main campus. So let's say we want an average for our main campus. We can very quickly do that with tools of step 1 is to create an array with booleans true for main campus, false for the rest. We only main campus true at all other positions. That's very easy. We will store this array in the main campus, but this is where the magic happens. Our location array is it equal to main campus? And because this is an array, it compares each. If this would be a list, it would just say false. This. But because it's an array, it will understand how this you want on every element. So we can run main campus. This one, main campus, which is location array, equally. What is the length of main campus? Centimeter. Main campus is minegram, integer, float, boolean. Mina. You look to this. What does this operation generate? Does it generate booleans or numbers? Booleans, exactly. True or false? Since the booleans are let me show it for you, the other one, and then let me ask my question. If I have array 1, yeah, and then I did array 1 bigger than smaller than 3. Since the booleans are just put in a button, so let me just boolean. In other words, you make them since the boolean. Boolean method. I'm saying method. Right? Just like here, we have the 2, and the 2. So now we will have 2. And so this is still 11. 2, That's just step 1. We create an array with booleans true for main and false for the rest. So boolean to boolean. Step 2 is to create an array with only the main campus temperatures. How would we do that? Now we're going to the answer. Because we say we want from temperature array on the computer, we don't want continuous answer, we don't want continuous answer. We want booleans main campus. In other words, we want to slice with an array of booleans. Boolean method temperatures. If we want to slice with a computer card, we need boolean method booleans. For every value, it needs to know true or false. So that's why it's very good that this one is 200 because we can slice it. We can now use temperature array and slice all these. Boolean method values are boolean method booleans are slice and for them. We'll give you only the answer. Making. So that happens here. Main campus step is temperature array for all these booleans. Boolean method booleans. Leaving me only the well, and then only one step remains. Why did we do this? Not to find the average, of course. So the third step is to take the average of this main campus temperature array. And of course, knowing that numbering is a model for scientific computation, there must be some averaging. Try to find the averaging function by typing np dot then guess the function. Now there is also already one shown in the script there is already one, but there is another one. So try to find, do not look to the script, but try to find yourself a function to take the average. How do you find it? Well, I found the function random by typing np dot round and then type. So now guess the function name, which is still in np, and see what it is. So type np dot start typing what you think the function name might be, the type to see what it is. So your goal is to find a function to take the average. So bracket open and then you can see what you need to do. So it's to use a function. And the small a stands for any array. So you can directly put the array in the other. Yeah, so this one indeed gives you the average, but there is another one. So, what would be a good name for the function? So, the function that takes the average, what would be a smart name for it? Yeah, mean
Average.
average. Yeah, you can. So you say average, so you can always check alle if you type alle. That's how you find new functions. By just guessing the name and typing. Yeah. Yeah. So, what do you think? The average, min sim aan. What is the function name of that function?
And it's also under
Yeah. Hoe let het? Kan het? Min function aan?
Mean.
Yeah, mean aan. Okay, and here a couple of people found it. So let me help everything along this whole process. If you have any function that you think, if you have any mathematics that you want to do, most probably they gave it a smart name. Yeah, mean is shown, but more logically, function for the average, a very logical function in the average. To know whether that name exists, I shall situate the following tab and then scroll through average. That takes a bit, you find it. But what you could also do is just start with at least that you think, oh, probably it will start with the A. Still a lot. So probably it will start with AB. Oh, yeah. The only function that starts with AB is average. And then you get to look how to do it. It needs some array, that's what the A stands for. So any array you can put in there, or any array like, so actually, it could also be a list. Axis is some default value, so you can ignore it. Weight is some default value, so you can ignore it. Returns is some default value, so you can ignore it. Axis will see later modules. But more importantly, it needs at least an array. Well, we happen to have an array. The main campus 10, which is all outside the main campus 10. And the average in my case is this. On your computer, it might be different. Why?
Random number.
We generate a random number. It's different. Yeah. So we have created, well, in the script I use np mean. That one also works. Np mean. Main. I think the biggest difference between main. Mean has the parameters array, axis, print type, visit. Average has also the argument weight. If for some reason you want to take a weighted average, so maybe you want to take the average grade, but the ministry says, well, the grades of status should be weighted a bit higher because they have more challenges. Then you can supply all grades, and you can say, well, this grade needs to wait for 100%, multi-percent, this one for multi-answer, this one for multi-answer. So, weighted average you can take with function average. If you just want normal average, average and mean give exactly the same. And the mean then will give me exactly this in this case. For some more specifics, they start to work different. Good. Now what you should all realize also, 1, 2, 3 steps, and I already regularly said, if you do multiple steps, probably you can also turn it into one step, or one line of code. So we now did it step by step, 1, 2, 3. But all the above steps can, of course, be combined into one. You can simply say, I'm going to calculate the average. Well, the average will be NP of mean of what? Of temperature array, P-honus, location array, equals mean. And so that's just integrating the creation of booleans into the slicing into taking the average. So the more advanced you become, the more Charlotte you get, the faster you become also in combining tools. And then, well, these 3 steps. First, you need booleans. These booleans you need to slice, and then you have to know the steps to take the average of. Well, you can take the average of one for which is it's exactly the same. So my examples maybe G2 is of course exactly the same as maybe. Same. Oh. Maybe some of you already saw my script related to the following question. Create full-for-campus STD, which is the standard deviation of all full-for-campus values. And try to do it with only one line of code. Just what's on my screen. The answer to that. But just based on what you saw here, do exactly the same, but now you don't want the average, now you want the standard deviation. But how to find a function in NumPy that calculates the standard deviation, and we build against the function. And then use this function for only full campus values instead of main campus values. So, minutes for clarity, you might want to call this but at least you can check it very normally.
Okay, this is the problem.
Yeah, well, that's just your own choice. Yeah, keep your script there or whatever. Ah, okay. So run with this one. So you can, for example, line. Yeah, just one day you simply run everything. It also works, but then you can follow the steps a bit less. Only these ones, I use now headline, which is just the same as this one is headline. And run the selection. So now, for example, so similarly, try to find a function that has a standard deviation. What do you think this function means? Yeah, so you can start with ST and check when you have returns a standard deviation. Looks like first argument needs to be some array. Okay, so then you need an array with arguments for, in this case, not for main arguments, but for couple. The name you should change it. This should be STD, and this should be. Yeah, that's all you need to change. I think some of you already found a function. With which function can you take the standard deviation? Yeah. So again, think standard deviation. Probably it will start with ST. Top. Okay, STD. Now, start using it to see compute the standard deviation. Well, that's exactly what we want. So this is the function we want, STD. Then I want to calculate put campus STD. This name is just for myself. It's zero influence on the script. The things that have influence on the script are, of course, instead of me, I need to do STD, and instead of the main campus for campus. And just like that, I have put for campus, which is a bit different for all of us because we use them. I'm just going to quickly show you one application. Not, it will be too fast probably for you to all copy it, but just to let you know, the more you start practicing all of the tools, module 1, module 2, module 3, the more things you can do. Because one small new thing. Last week I thought probably if I want only the unique values, probably numpy is something for that. So let's say I want the average of not only main campus, but only group campus. I want it for all four. earlier steps, for the ones that followed it 4 weeks ago, it's a bit long ago, but we need to find all unique campuses, and then for each campus we are going to look through the campus and take the average. Now to find unique campuses, earlier we used a loop, but last week I just thought, well, maybe nobody has something that does unique. What would be a nice name for that? To abstract all unique values. Unique. Let's check if we do location array in there. We get just an array with 1, 2, 3, 4 values. No, so I can. If I would have bulleted sheet registrations for alumnus integrated alumnus methods, I can just quickly get the unique locations, and then I can have one successive value. And that's on the same portion. Locations is this. We created it ourselves, so we know our location, but let's say we import data from the owners, then also we would now get the owner's house or unique location. That's the location. Then I'm going to look through this for what do I want every group? I want the average. So I'm going to create an average list. By the list in which I will store the averages. And I want Arreta on per location, I want an average. So per location, I want to do this. Which is the mean of temperature and location array for which it is not main campus, but majority iteration, main campus, bulletin iteration. In other words, or not even. I want to make sure that I'm taking these campuses. I have here a collection of all campuses, so I can do over this collection. For some location in locations. What is locations? You check my code. Locations minimum. It's an array of Arreta unique locations. Majority iteration location minimum. Yeah, my loop will move through this one. So majority iteration will be. Well, that's exactly what I mean. Here, each time I take the later operation. This one, majority iteration will be majority and negative. So if I have bullet emitter locations in here, I will create bullet emitter iterations. And then I quickly calculate the average, and then of course I can use our list tools, the module ant, and we also use the module ant, so that every iteration I calculate the average. So majority iteration I calculate the good Java campus, and I append the Java campus. Bulletin iteration, Google and calculate the so with this is called activate. Let's say I want some more information, I also want the median list. What is the median? Center. Yeah, exactly. It's not the average, but it's the
middle value.
All from small to high, the middle. What do you think the function is to take the mean? So we just assume nothing. Visual mathematics, probably there's also a function to take the mean. What name should we use? Right? Median Anna. This is almost become too easy because I can just add to this median. It's the only thing I need to change. The rest I can keep the same. And then I can also say that yeah. F9. And just under the second, I've created average list and median list. For now, which are other locations. But I hope you realize that this could also be for all places of Ethiopia. If you have a very big list of 20 years of data for all locations, well then make sure it's in one big array. And then you can add any mathematical parameter that you want. You can just enter it into the loop, and for the rest it's up to you in what you want to save it in a list. So the more you know your tools, module 1, module 2, and the faster you can get the values you want. So then already as a researcher, you can start spending time on what is interesting to know instead of how do I get it. The tools allow you. The challenge is to realize what actually do I want to know? Do I want to present to you? Do I want to present? So behind je Python geloven, je moet dat the challenge of research is shifting from how can I do it to what is actually relevant. I think that is a very important shift. Okay, that was just a quick example that shows you how powerful Python can get. NumPy functions. Several mathematical functions are available. NP average with opportunity to weight average, NP square root, NP log, NP sin, geometric mean is not in there, I think, but most of them are. Read the docs to find out more. All good Python packages have an extensive website with extensive documentation. So if you just on Google look for NumPy documentation, then you will find this website on which there will be pages on what is NumPy, how to install, quick start, absolute beginner's guide, and after the documentation, all the functions they have with very useful examples. Bazoo. Only one function I still want to share with you, the function NP and it stands, I think, for array range. Do you still remember the function range? Range 20. What does it do?
Zero. I was starting from 0 or
0 SK?
20. No, as well.
SK higher defeat. Exactly. And you could also say range ant higher comma bullet, and then you will get starting from ant SK higher defeat in steps of 2. NumPy is a function that is very simple. One very useful function is np.range. For integer arguments, it's just similar to range. Almost similar. The only difference is it directly also creates an array. If I have range 20, it creates this range in which I don't see all the numbers. So I need to bring it into a list to see all the numbers. np.arrange 20 directly creates an array. So I directly see all numbers. Array. This is the first difference. But more importantly, you can also use it for non-integer numbers or non-integer arguments. So if you say np range 0, ant, bullet, it will give you an array of 0, 0, 1, 2, 0, 4, exactly what you would expect. But the function of range is not possible. Range 0, ant, 0.2, actually only integers. Float object cannot be integer. With NumPy, a range, which is 0, 0.2. So this is very nice. And let's do this question together. What do I need to type to create the array 5%? So 5%. I want an array of all values from 0 up to including 1 in steps of 0.0. I'm going to do that with np range. What do I need to put in?
0, 1,
0,
1, 0, 0,
If I don't store it somewhere, it's on my screen, but if I provide some name, it does not go to my screen, it comes into the name. That's why I do not directly see it. If I want to see it, curriculum, including one. How to include one?
1.0.
0.5.
Curriculum, but
Zero.
now
No. 0.
So 1.05.
1.0.
0.5.
Let's say, or 0.1. Yeah, 0.5. Yeah, that's it. So this is a very nice array to put on my graph axis if I want percentages on my plot. And so a range is very powerful to create quickly numbers, and it's a bit more powerful than a range for two reasons. You directly have an array. With this array, you can directly start to do your mathematical calculations, and it's also possible to float current. But that was good. Yes. Then the final Arbadeka I want to start with pandas. Escasivas. Yeah. So we saw arrays, which is a new collection, an external collection, and with these arrays we do a lot of things, but we also saw the number, the zoom data function. Now let's move to importing data with. And we will move to M3 PD data. So open M3 PD data. One last. So open M3 PD data. And for the remainder of this morning, as well as next week, full morning, we'll be working with this script. Importing data with pandas. Pandas can import data from several types of sources. For example, from a CSV. You can easily import data from a CSV. We already did that in module 2. And we did not went into detail. Also, then we said import pandas as PD and then PD will be CSV. Now you understand why it happens. Because the guys at pandas have programmed very nicely a function with which you can build files. So to use that function, you need to import pandas, what we do also this, and we import it as PD, so all pandas functionalities are stored under PD. We will import data from M3 air quality.csv. Let me quickly show you main data. When you start working with your own data in Python, it's very important to know metadata. You need to know what you are importing. Of course, you can also randomly, blindly import it and start to check it in Python. But when you really start data processing, you should also know first what is it. So let me quickly show. We're going to import this M3 air quality. What is it? In there are Azure system, in which the material left are bad for Semanya statistical observations. So Semanya statistical observations of what? Of each time it tells us the time zone, but that one is L what we are saying. But it tells us the time. As you can see, it's good data measurements. What are these measurements? Well, in there I also included which day it is. So this is all the first day, and later the second day it is different. This is an air quality measurement instrument which is in front of my house. And I simply used, this is only just the word of this data. So this is just the word of air quality in front of my house. So this is private information. Which information do you find in there? some United States air quality index, some Chinese air quality index. That is just kind of subjective parameter. How is that? As you can see, the Chinese is always lower than the United States one. The reason for that is that, for example, in Beijing, so if they would use the United States scale, they would continuously be at the worst end of the air quality. So they just invented a scale that is a bit low. So their air is not cleaner, it's just they use a different level. More importantly, this is where we get the measurements. We have PM2.5, which are small particles in the air, there's the number. PM10, the somewhat bigger particles in the air, carbon dioxide, that is familiar to all of you. We also have temperature in Celsius and temperature in Fahrenheit, and we have relative humidity in percentages. And besides that, there is also some important organic carbons, but my instrument does not measure that, so Semenya sheet curve minute values for all these points. If you would like to start processing this in Excel, very soon Excel will crash. If you start taking average for a certain data, it's simply too much. The Python checker. Data reduction. Yes, so this data we will import. Pandas can import data from several types of sources, for example, CSV file. Maybe we will import it from this file. Make sure that you have the file not open, otherwise Pandas might not be able to access it. And if you are using it in Excel, then another program can use it at the same time. And we just import the data with one line of code. From the module Pandas, CSV, under there is a function read CSV. And in there, we give a file name. Well, the file name is m3airquality.csv. It is stored in the folder data. This will only work if your current working directory is your project with the folder data. And if the file is in this folder data. That's related to this one. This one needs to be at basic Python project. And so Python starts reading here, it's a basic Python project, in that data and CSV. So run only that line, import one XPP, and just like that, we've imported Semenya sheet curve rows of answers columns. We'll check this data in a moment, but let me zoom a bit more in onto read.csv. This function, read.csv, we can read CSV. And there are many possible arguments to this function. If you would start typing it, you would get this big list with all kinds of arguments that you can see. Because different data in different files can be in different formats. So this provides a lot of arguments to supply this function. Just like you made a function group position with two arguments, they create a function with arguments file name, but also how are your columns separated? Do you want to use all rows or do you want to exclude rows? Is your first row header line or is it directly data? Limit nugget the chat. So limit options. And I hope you remember function keywords from default values. From module 1, the very first one, so you can zoom it. I think about Silasa arguments are. Which for all of them except the file name, default values. So if your data is known, you only have to give the file name. Later has the 10 arguments by default. If you want to use the argument that explains the other headers in your file or not, you can use that argument as keyword. You can say file name, comma, header is something. True, false. I will consider your argument header now. Considering because you use the argument as keyword. There are many possible arguments to the function PD. The only really needed is file path. So that's what we do. Yeah, we only supply file path. However, depending on your file, you might want to change and just pick out a few from the set or limit. If your data is not separate, this data is separated by comma, or sometimes data is separated by tab or semicolon. So then you can add the keyword set is whatever your secret is. Header, if your data has no header, it assumes the memory line header node. Can be only single children, you can say header is false. No header. Names. If you want to provide a header yourself, you can add names and then add the names that you want. So do not take the names of the columns from my file. I'm supplying them myself. For only importing part of it, specify something with a use call. Only take legitimate source columns. Data are not interested in it. Skip rows. Skip memory. We'll have no rows because that is all like instrument information. And after that, the real GPS data stuff. Or number of rows, only import memory. How many rows? Because I just want to test a bit and then I want directly moving million rows. If you want anything else, just look around in all possible keywords and follow up their advice. Additional help can be found in the online books for EO tools. So if you run into some error while importing your data, you can just hit play at Google Pandas implementation EO tools. Very clear distinction. On it. Good. We imported the CSV file. We can also import data from a text file. And just to show you, it's also possible, I also included M3 equality.txt. It's exactly the same data, but in a different file format. And now that is a text file. And as you can see, all columns are divided by tabs and not by commas. So I need to make a small change. To read a text file, we can just use the CSV function. So read CSV, you can also use to read text file. But make sure to select the correct set. In the case of this file, that is tab. And in Python language, that is quotation mark \t. But you can find more of it later. For now, it just suffices to say we need to again supply a file name and path. But also we have to explain it separated down name. Tab instead of the default comma. That also works. Point intermezzo for a file path in a string always use the forward slash. Data forward slash. The backward slash is so-called escape character. We might come across it later. But more importantly, the backward slash in combination with E is used to tell Python we need tab. So this needs to be a backward slash. This needs to be a forward slash. If you mix them up, then you have the we'll see a bit more detail of this. But for now, just remember file names forward slash. And you go back. Yes, so also we can load this high quality data as text file and just read this one. That also works. Finally, I want to show you that we can import an Excel file. Now, Excel files are a bit different. So for Excel files, they really needed to create a totally different function. They did that. They created the function read Excel. Like PD read CSV, read Excel has many possible arguments. For our case, we really only need the file path and sheet in Excel. Your data is always organized on different sheets. And so you have to explain it. So we can read from Excel, PD.read Excel data, equality.x86, sheet names, my data program. So you can run that one as well, and you will see, I'm not going to run it now. It probably will take you a bit more, because Excel files, the data in an Excel file is stored a bit more complex on your computer, so it takes quite a bit more time to get it out. Okay, that was a bit more detail of how to import data, but the main message from this is getting the data into Python without Lambda. Yeah? Just one line of code, but you need to make sure, well, you might need to spend some time on additional arguments, but if your data is just very normal, only the time is enough, and then you have your data in. Now let us check what we got. And from now on, we'll just be simply only working with the AQ data text in Excel are just exactly the same, but to show you that also text in Excel works. So let us check what we did. For example, I just say, what is this AQ data? AQ data, enter. And then you will see. Hi, what is different here? It's looking in for the code, so you need to go one time. Because the folder data is not in code, it is in this. So click on arrow. Yeah, that's so that was fine, especially with this. Actually, one small thing. If it's only one line of code, you don't even need to select. Because this is room selection all putting line. So this is unlimited selection. Just click on the line. Yes? Meta? Meta? How are you? Again, Meta? You get? One more jet.
No. Should I select all the things?
Oh, no, that's not needed.
So just only read this one.
Forward fast, it is oh, where are your Python materials? Where, okay. Where are you? Meta. Thank you, data meta. Yeah. Yeah. One line. Yeah. AQ data. Good. What's the length of AQ data?
ሰማንያ አምስት ሺህ ዘጠኝ መቶ ሰላሳ ስምንት
Yeah. So minus the sheet group. And actually, we could have seen that also already here. If we just check AQ data, the guys at Pandas have done some nice programming that it nicely looks like a table. And if you ask it Moodle, it's not dumped Moodle on your screen. If you ask for a list, you get Moodle list. So list plus minus the sheet group. Now the guys at Panda programmed that you also just see the generator finish, jet setting, and not only for the rows, but also for the columns. But you see it like this, it's very special. because Python is not for visualization. Excel is to nicely visual. The guys at Pandas have programmed it that it becomes visual again. So this nicely looks like a data. The length of AQ data will tell us center row center. So not center column, center. What is AQ data? Min and variable. Min and variable.
It's a data frame type.
Yeah, it's something entirely new. It's not a list, it's not a queue, it's not linked. It's something they created themselves. Earlier, we saw that, for example, there for some lists, we could see all list options. Now let's see all built-in AQ data options. For lists, append, replace, data. So with there you see all built-in methods for data. If you do that, then you see, with their PD, were a lot of things, but if we do there with some data frame, we also get a lot. These are all things we can do to our data frame. And you can already see from the names that it's a lot of data processing. There's even some statistics in there, we can do some correlation. But we can drop also something, so remove things. We can explode a bit. I do not really know what it does. We can fill, and I remember that it's short of forward fill. This is to quickly fill missing data based on the method forward fill. So if there's missing data and you use data frame with forward fill, it will fill the missing data based on this value. It will just copy to the next page. So linear methods are that are good for data processing. The guys at Pandas are experts in working with data, and they shared that with us through this. So linear methods. And two specific things. We now have two-dimensional data. Yeah, one list is just one dimension, so we have one index. But we now have two dimensions, rows and columns. AQ data dot index gives us all indices. And as you can see, that's just a range from 0 to Kassan. That are kind of the names of our rows. So rows, generally a row has to go to 0. Bullet and a row has to go to bullet. Indices. Besides that, we also have names for the columns. Two dimensions. We have this, but also these. And those we can find by saying columns. With both columns, we get this dimension of the names of the columns. So those are two useful built-in tools. In other words, we loaded data of semi-established rows. All of this data from Pandas automatically per row got this index. It also got these column names. That was not automatically. That is just because Pandas assumes that the first line in our file is headers. And in this case, that was luckily the case because, as you can see, it just copied the names from here. And these are column names. So if I would not have this line, then I would change my import statement. And I would explain to my header is false. And then I could say the names is supply my own names. In this case, we have headers so that it nicely ends up in the column names which you can find through the built-in columns. Good. Collections. Pandas data frame and series. We so far saw that built-in collections list tuples, dictionaries, and the external collection of people. Pandas has also two collections. Data frames, which you saw an example, and series. With Pandas, you can work with tabular data. Data like a table. A data table in Pandas is called a data frame. So the variable type is data frame. It's a special collection. It's not a one-dimensional collection, like a list or a tuple or an array. It's a two-dimensional collection. It always has certain rows and certain columns. Each column, so if you only have one column, that's also called a series. So with Pandas, you can create just a one-dimensional line, series, or you can create a nice table, and then you have data. Each series or data frame has, of course, some index. There's some way to say, well, I want to now only deal with these groups. If not specified, this will be simply 0 up to the end of the data frame minus 1. And it will just be some range. You can, if that is relevant for some reason, also specify the index yourself. For example, during importing. You can say during importing this file, for my index is, and semantics is secret roster, so then you need to supply semantics to the secret symmetry. And then it will not be 0 expect something. So Pandas combines a bit of both. As in tuples and lists automatically generate the image. Or dictionaries. If you want, you can create the image yourself. Pandas is the best of all. It just combines the different ingredients of the different collections. In a data frame, you can store anything. In our data frame, we simply have strings, like time, integers, data, context, floats. You could also store lists, arrays, or dictionaries, or data frames, or any other objects. You can store anything. For example, I could create for my own faculty a data frame for water supply. Within that one data frame with all personal information about lecturers, another with all info about students. And then in that one for students, I have student names, numbers, hometown, but also grades for year 1 and 2. So you can make it as complicated as you want. But most often you will simply be working with footage and strings. Now, let's still see how we can access data. Accessing data in a data. So we now move to this part of the script. If you only want one series out of them, one column, then it's very much similar as a dictionary. You just use the column name. So you can say, from Enkydata, I want only the column temperature Celsius, and then you have to use exactly this. So there is the column temperature Celsius. Here it is Enkydata. Weekly experiment, temperature Celsius, and that's getting me only all values for temperature Celsius. Now, often the series name become attributes to the data. What do I mean with that? Then you can also use data frame dot series. So you can, for example, use data dot data. But it's only possible if the name has some spaces. our case, this one is a bit annoying name. Temperature space Celsius. And if you would do this, AQ dot temperature space Celsius, I think you remember Python does not understand this. Yeah? And it thinks AQ dot temperature, and then Celsius, no, error. So this is not that. But there is one other one. This data space element. So for that one, Pandas make sure that it's directly available like this. Here. And that is Yeshiva, because then dot day time, you can hit tab, and then there are two options. You move to data, so I don't have to type it through myself. So you could spend your time a bit in Excel or during input to change the column names to make them a bit more efficient. Column name with space guide only accessible with this. Column name yellow space also accessible with dot. And so to get the data, we have two options. We can also do the data. Time, dictionary style, but AQ data dot data. Good, that is how we get one column. If you only want one row, we need a bit different tool. Because this method is already reserved for the column names. Here, we can use data. So we cannot say 0, because then it thinks you need columns in. It will say key error. There's no columns in here. There are only these columns here. So for that they made a new function. They made a function log. That is to tell the Python I'm talking about the rows log operation. And to that we can directly use new use. And then it's presented like a small table, but as you can see, this is just a generic row with column time and the all information for row 0. Well, of course, if you only want one cell, so you want a certain column, and from there a specific row, one cell, combine the tools you have. So start with series name, and then the index, or start with dot log index, and then the series name. It's just a combination of both tools. So, for example, if I want the row out not of temperature Celsius, I can make it like this, or I can say first move into the row and from there Celsius. It doesn't really matter. This one is a bit more efficient. As you can see, I don't have to use log here. That is because if I move into temperature Celsius, then I just do this. If I move into that, it's clear. If I slice to 0, it's clear. Oh, you simply need this one. So I don't have to use .log because it's already clear how this course implies rows. So this one is a bit more efficient. If you first move into rows, then of course you cannot say 0. And in that row, it's just like earlier we combine multiple steps. Because this gives me another collection. From this collection, I want this one. So I use this one, I slice to this one. So, with which command can you get the value that is in row 800 of the series CO2? Yeah. What do I have to change here to get from row 800 series CO2? ppm? What do I have to type here? Yeah, here you see an overview of the names. It needs to be exactly this one, of course. Yeah? So it needs to be CO2, ppm, and then instead of 0, you take 800, and then the cemento ammonia carbon dioxide. Okay. Yeah, we can just also still finish with how to get the multiple. Because now we get one value, one row, one column, or a combination of both. If you want multiple rows, it's just exactly the same like earlier slicing. You can use AQ data dot local. But if you don't want only 0, but you want Majimeria as an image, you can say 0. Very small thing that I discovered during the training. For some reason, I think it's a small mistake, but never mind. Function log works tiny bit different than normal slicing. 0 SK Adramis. What would we normally expect as an Cherisha row? Azraat. As you can see, you get it as SK Adramis. So the function log is from here up to and including. Yeah, it's just how the guys can find out. This shows you don't necessarily have to remember this. You simply have to remember always when you start working with data, check the data, when you get what you expect. And you easily will find, oh, I get one more. Oh, check your data. So that is how you get multiple rows. So, for example,